Let's go through these one at a time. Now, given any graph, can we say that Clever VC will outperform our factor 2 approximation algorithm? Now, this is actually false. Well, it seems like it outperformed our factor 2 approximation algorithm in each case we tested it. In order to actually verify that it will outperform our other algorithm, we would either have to test it against every possible graph, which is somewhat impossible, or we would have to give a mathematical proof that Clever VC will outperform our factor 2 approximation algorithm in every circumstance. And since we haven't done that, we can't actually say that this is true. We also can't say with certainty that Clever VC is a factor 1.75 approximation algorithm. And that's because, well, we can't see the source code at all. If we can't see the code, then we can run tests and be more and more certain whether or not it's a factor 1.75 approximation algorithm. But we cannot be certain. So we can't say that this is true. However, we can say with certainty that Clever VC is not a correct algorithm. Now, why is that? Let's look back at our table here. Now, the key thing to notice here is that the algorithm we're comparing Clever VC against is a factor 2 approximation algorithm. That means that each of these numbers, each of these minimum vertex cover sizes, is at most twice the actual minimum vertex cover. So let's think about what that means. That means that the minimum vertex cover for the 10,000 vertice graph is actually at least 284. And let's go ahead and round up here. Similarly, the minimum vertex cover for the 20,000 vertice graph must be at least 117. For the 30,000 vertice graph, the minimum vertex cover has to be at least 300. And this is the key right here. So the minimum vertex cover, the absolute minimum vertex cover of this graph has to be at least 300. But Clever VC is saying it found one that is only 295. So that means that this is wrong. This cannot possibly be if this is a factor 2 approximation algorithm. So either this isn't actually a factor 2 approximation algorithm, and let's say that we verified that it is, or this is not a correct algorithm for finding the minimum vertex cover.